Well, hello. This is your first lesson in algebra. So just a couple of side notes. It is really important that you don't just sit back, relax, and just watch the video without engaging in some sense. And what I mean by engaging is you want to be taking notes. Now, whether those notes are in just a regular notebook binder, I would highly recommend getting a notebook that has the graphed paper, because a lot of the stuff that we're going to be doing, especially later on in this book, is going to be dealing with graphing. And if you have graph paper, it's going to make it a lot easier as you're taking notes and to create graphs that are more accurate than what you would get just from a lined paper. So that is my recommendation, but not obviously a requirement. But it's really important that you learn how to take notes in a math class. And so as you're watching these videos, remember it's a video, so you can pause it whenever you want. You can replay it if you didn't quite click for you. So take advantage of that. And oftentimes I'll even say, pause the video, try this problem on your own, and hit play when you're ready to check to see if you have the correct answer. So it's important that you do that. Don't just sit back and wait to see the answer. It's important for you to try it as well. So with that, let's go ahead and get started on this first lesson. So as you can see, we're focusing on what's called the commutative and associative properties. Those are some words that sound kind of big, and they're not words that we use very often. Even in math, they're not words that we use very often. But the thing is mathematicians are never happy with just saying that the reason we can do something is just because. Even though in real life that's an excuse we like to use, in math we always have to have a reason for why something works. And these are two properties that allow us to do different things in some of our math problems. Things you've already done already and you didn't even know it. So let's look at the first property, which would be the commutative property. So first thing I want you to do in your notes, write down that word, commutative property, and write down this definition. So what is a commutative property? It's when changing the order results in the same solution. Okay, so where it doesn't matter what order we do something is referred to as the commutative property. Now there's times where it works and times where it doesn't. So we're going to look at some different examples here with addition, multiplication, subtraction, and division to see in which of these circumstances the commutative property works and which ones it doesn't. So let's look at the first one with addition. So for example, 3 plus 7. Obviously 3 plus 7 is 10. So far so good. Now what would happen if we switched the order if it was 7 plus 3? Well, that's also going to be 10. So we can put a check over there next to addition to say that yes, the commutative property does work with addition. So it doesn't matter what order you add things in, you'll still get the same result. Let's look at multiplication. So if I had 3 times 7, well, 3 times 7 is 21. What happens when I switch the order? Well, 7 times 3 is also 21. So we can put a check mark next to multiplication as well. So multiplication also, or the commutative property also works with multiplication. What about subtraction? If I have 3 minus 7, 3 minus 7, that's kind of a different one because you're subtracting 7, a bigger number, from 3. So that's going to result in a negative number. We get negative 4. What if I switch the order? If I had 7 minus 3? Well, now I'm subtracting a smaller number from a bigger number. So 7 take away 3 would be a positive 4. We got different answers when we change the order. So subtraction doesn't work. Our commutative property does not work with subtraction. Let's try it with multiplication though. Let's say division. If I had 3 divided by 7, well, we'll just leave that as a fraction for right now, 3/7. So that's a fraction that's going to be a result that's smaller than 1. If I switch the order, if I had 7 divided by 3, again, let's just leave this as a fraction. 7/3 is an answer that's bigger than 1. So these are clearly not the same result. So the commutative property does not work with division. So to summarize, the commutative property only works with addition and multiplication. What about the associative property? Now, the word associate is kind of hidden in there. If you think about who you associate with, it's the groups of friends that you hang out with. So the associative property is saying that the way you group numbers does not change the solution. So again, we're going to start by looking at addition, multiplication, subtraction, and division to see which ones of these the associative property works or may not work in. Let's start with the addition property, or addition. So here we have 8 plus 4 is grouped up on the left side of the equation to say that 8 plus 4 and then plus 2. So remember, order of operations we would do inside of parentheses first. So on the left side, we have 8 plus 4 grouped together first. On the right side, we have 8 plus, and then the quantity 4 plus 2. So 4 plus 2 is grouped together differently. All right, do you see that? So let's see if we get the same results. So to start out with, 8 plus 4 would be 12. And then we would add 2. On the right side, if we did the 4 plus 2 first, we would get 6. And 12 plus 2 is 14, and 8 plus 6 is also 14. So the way we grouped those things with addition didn't change the answer any. So the associative property works with addition. Now the reason why that's useful is sometimes we might have a string of numbers that we're adding together. And maybe instead of just adding from left to right, maybe it would work out easier if we chose to add two numbers from further on together and add those together and then add some of the other ones together. Maybe that makes it easier to do without a calculator. So the associative property allows us to do that, to change the order or to change how we group together the different numbers when we're adding. But what about multiplication? Does it work then? Let's try. So here we have, again, 8 times 4 being done first, and then we're going to multiply by 2. On the right side of the equation, we have 8 times 4 times 2. So what we're doing here is we're trying to see, does the left side and the right side equal the same thing? So if we do order of operations inside the parentheses, we would get 8 times 4 is 32. And then we would have to multiply that times 2. On the right side, we'd have 4 times 2, which is 8. All right, so now we're going to have 8 times 8 on the right. And if you notice, both of those end up equaling 64. Now, did you find that taking 32 times 2 was trickier? Some of you guys might have gotten that right away because you just realized you had to double 32. But for some of you guys, if you were thinking that, man, 32 times 2, I don't know how to do that, maybe it would have been easier to do the other way. So again, the associative property would allow you to multiply them in a different order. To get that 4 times 2 would be 8, and then, oh, well, 8 times 8 is 64. That's the purpose of these properties. So again, if you look, both the addition and both addition and multiplication work with the associative property. But what about subtraction? And what about division? So let's say if we had 8 minus 4, and we did that first, and then we subtract 2. Or let's say if we did 4 minus 2 first, and then we're going to subtract that from 8. So order of operations, let's do in parentheses first. So 8 minus 4 is 4. And on the right side, 4 minus 2 is 2. So now if we simplify both of these, 4 minus 2 on the left side would give us 2 as our answer. But 8 minus 2 would give us 6 as our answer. So clearly, those are not equal to each other. So we would say 2 doesn't equal 6. So the associative property does not work with subtraction. So we'd have to do it in the order that was given to us. We can't change the order, otherwise we're going to get a different answer. What about with division? If I had 8 divided by 4, we did that first, and then divided by 2. Or if I took 4 divided by 2 and took that answer, and 8 divided by that answer, and see, do we get the same answer on the left and right sides? Let's check. So 8 divided by 4 is 2. And on the right side, 4 divided by 2 is also 2. But do we get the final answer being the same? 2 divided by 2 on the left side would be 1. 8 divided by 2 is clearly not 1. It's 4. So 1 does not equal 4. So the associative property does not work with division. So you can see that over there. Neither of those work with the associative property. So to summarize the associative property, just like the commutative property, the associative property only works with addition and multiplication. It does not work with subtraction or division. One last thing before we're done with this first lesson. In your assignment, you're going to be working with exponents. So I just want to review exponents because it may have been a while for you. So this little concept here. Negative 4 quantity squared versus negative 4 squared. Eventually, you guys are going to get to use calculators. And it's super important to know how to use a calculator. All right? If you type in negative 4 squared, or if you type in parentheses negative 4 squared, you're going to get different answers. Let's see why that would be. Let's start with the quantity negative 4 squared. Think about it for a second. What does it mean to square something? Do you remember? Well, hopefully you remember that squaring something means we multiply it by itself. So negative 4 quantity squared means you'd multiply negative 4 times negative 4. And a negative times a negative is a positive, so we'd have negative 4 times negative 4 would be a positive 16. Let's compare that to negative 4 squared, just negative 4 squared. Well, when you see it like that, the only thing that's being squared is the 4. So we would have negative the quantity 4 times 4. So 4 times 4 is 16 because we're only squaring the 4, and so our answer in this case would be negative 16. So negative 4, the quantity negative 4 squared, is not the same as negative 4 squared. That's really, really important to make sure you understand. All right. So that completes this first lesson. Hopefully that made sense to you. If any of this didn't make sense, or if you need to go back and review, obviously you have the advantage of having a video, so you can watch it as many times as you'd like. And also, if you, as you're going through that, if anything went fast, make sure again to go back, pause the video, make sure that you have everything written down. Because you're not going to want to go back to a video to try to remember what it means by associative and commutative properties, like in a few lessons after it's been a few days and you're doing your homework. You don't want to try to go back and watch previous videos. It's much better to just have your notes, be able to flip back and instantly see, oh, that's right, that's the difference between commutative and associative properties. So taking good notes is going to be really essential for this class. So good luck now as you work on these assignments this week.